Okay, so we're going to have a look at a chi-square test then, and why we're going to use a chi-square test and what the chi-square test tells us. So a chi-square test tells us if the difference between an observed value and an expected value is caused by chance alone, which essentially means that they're no different to each other. However, if the difference isn't the result of chance, then there must be a biological cause for the difference. So a chi-square test tells us if the difference between observed and expected values can be explained by chance alone, or if there is a biological reason for the difference. So in our chi-square analysis, we're going to use our F2 data, which is the actual number of tall and the actual number of dwarf plants as our observed numbers, and then we'll compare the observed numbers to expected numbers of plants. Now in our case, our expected numbers will be calculated from the expectation of a 3-to-1 ratio of the number of tall plants to the number of dwarf plants. Now we're going to use a 3-to-1 ratio because we're first going to determine if the inheritance of height in brassica plants follows a Mendelian pattern of inheritance. Now if it does, then we'd expect a 3-to-1 ratio in the number of tall to the number of dwarf plants in the F2 generation after we took true breeding parents, crossed them, and then crossed the F1s with each other, which is exactly what we did. So if our observed number of tall plants and number of dwarf plants in the F2 generation is no different to a 3-to-1 ratio, and that's what our chi-square test will tell us, then height in brassica plants must follow a Mendelian pattern of inheritance. And Mendelian inheritance can explain how height in brassica plants is inherited. Alternatively, if our observed number of tall plants and our observed number of tall plants in the F2s is different to a 3-to-1 ratio, and again, that's what our chi-square test will tell us, then height in brassica plants does not follow a Mendelian pattern of inheritance. In this instance, Mendelian genetics can't explain some or all of how this trait is passed from parent to offspring, but maybe another mechanism can, something like polygenic inheritance or incomplete dominance, or something entirely new to science.